Okay, tied to the algebra tiles is a concept of using the area model as well, that many people refer to it as the box method. I've heard the window pane method, but it's still the area model. And so my model, very similar to what I was looking at with the algebra tiles, is I've got 4 panes to this, if you're calling it a window pane or the box method or whatever. The rules are fairly, it's a procedural thing. It's to help the students stay organized. It's to help them move from the concrete of algebra tiles to the more abstract, but to give them a systematic way of looking through that problem. So this is what I'm going to put up here in my x squared position. Whatever it is, my coefficient in this case is 1, so I'm good. I'm just going to leave it that way. Whatever this number is goes here. And if you think about what we just did with tiles, my x's went up here and my single tiles went down here, and then I filled in with the x's. That's the same process I'm using here. One of the methods people use to help find these numbers is something like this with the little x, where a times c is going up here and b is going here. This is to help the students locate factors. Well, 1 times 6 gives me 6, and my b is 5. Now, the question becomes, what multiplies to give me that number up here and adds to give me that number here? And with 6, my numbers would be 2 and 3. 2 times 3 gives me 6. 2 plus 3 gives me 5. So that's where those numbers are coming from. An alternate to that some people use is the ladder, where the 6 would go up here and the 5 would go down here, and the same thing is happening. What do these two do? Multiply to come up here, and what do these two do to add to come down here? It's the same process, it's just with the x. So my factors are 2 and 3. So I'm going to fill in with 2x and 3x. It does not matter where you put those two. You'll get the same factors. I'm looking at my first row here. What factors do these two have in common? They have an x. What factors do these two have in common? They have a 2. What factors do these two have in common? They have an x. What factors do these two have in common? They have a 3. They're all positives, so my answer would be x plus 2 times x plus 3, messy, or x plus 3 times x plus 2, or whatever convention they normally work with. Similar problem to what I just had, which is I just factored x squared plus 5x plus 6. Now I have a minus 5x. So I'm going to start with the same process. I'm going to draw my graphic organizer, box, window pane, whatever you want to call it. Similar to the tiles, I'm going to start with my x squared here and my single numbers here, my constant. And because this is a positive 6, I know something about these two factors. They both have to be negative, because a negative times a negative is a positive. So I'm going to go ahead and put my negatives here because I know both of them need to be negative. Now I'm going to go to my x, and my number here is 6, because again, a times c, 1 times 6 is 6. My number down here is negative 5. So I'm looking for numbers that multiply to give me 6 and add to give me negative 5. And those numbers are going to be negative 2 and negative 3. I'm going to put the 3 down here this time and the 2 up here this time, so we can see that it doesn't really matter where those x's go. So I have negative 3x6 here, negative 2x6 here. So my first row, what do these have in common? They have an x. This negative is what drives the commonality in a minute when we look at with the 6. So what do these two have in common? They have an x. So because of the negative here, the factor I am going to pull out is the negative 3. This is what's driving it. So the factor I'm going to pull out this way is the negative 2. And I'm getting it from the negatives associated with the x value. So my factors would be x minus 3 and x minus 2, or x minus 2 and x minus 3. here. We have x squared minus x minus 6 to factor this time, and I have two negatives that I need to worry about, so signs with my integers will become extremely important as I'm working through this problem. But I'm going to go through the same process that I've been going through. I'm going to create my graphic organizer. I'm going to put my x squared here. I'm going to put my negative 6 here. When I go to this x to figure out what my factors are that I need, up here is going to be a times c. Well, 1 times negative 6 is negative 6. My coefficient to that x is negative 1. You may want the students to be writing that negative 1 in the problem themselves so they see that there is a constant there even though we don't write it. So I'm looking for two numbers that multiply to give me negative 6, so one has to be a positive and one has to be a negative, and adds to give me negative 1. Negative 1 is a pretty small number, so the two numbers that I'm looking for have to be very close together. So my numbers are going to be 6 and 2, because 2 times 3, 3 and 2, I know that's a 3. 3 times 2 is 6, and 2 and 3, when I subtract them, I get a 1. So the question becomes which is the negative. Because it's a negative 1, this needs to be the negative 3. So negative 3 plus 2 gives me my negative 1. Again, it does not matter where you put those two factors over here. So I have my 2x and I have my negative 3x. When I look at this row, what they have in common is x. When I look at this row, what they have in common is 2. Whatever sign this is of the x is the one that's driving the sign that will come out. So since that's a positive, I'm taking out a positive 2. Going this direction, they have an x in common. And again, the sign here is what's driving the factor that I want. Since that is a negative, I am going to take a negative 3 out. So I have x plus 2 times x minus 3. And these need to be different signs because a positive times a negative is what's giving me the negative. Or I can have x minus 3 times x plus 2. And again, the negative needs to be there for the 3. This time my x squared has a coefficient other than 1. It has a 2. But I've learned the process, so I'm going to stay true to my process, and I'm going to have great faith that this is going to work out. So up here, instead of just x squared, I'm going to put 2x squared. And my constant is 3. Now going to my x, if you recall, up here we've been doing a times c. Well, in the past, a has been 1. A is now 2. So 2 times 3 is 6. And then my b is 7. I am still putting the constant from the problem in here. I still, if I were modeling this with tiles, only get 3 tiles here, even though I'm going to look for factors of 6. So my question to myself is what multiplies to give me 6 and adds to give me 7. And although I've been using 2 and 3 a lot for 6, it does not work here. The other factors, and the students do not always see the factors of 1 and the number itself. But 1 times 6 does give me 6, and 1 plus 6 gives me 7. So I'm going to put x here, and if you want, I can put a 1, and a 6x here. When I look across and say, what do these two have in common? Not only do they have x in common this time, they have the 2. What factors do these two have in common? And the students may not see at first that everything has the factor of 1 in common. And so you may need to help them understand that the factors of 3 are 1 and 3. So I have a 1 in common here. Going this direction, they have an x in common. And going this direction, they have a 3 in common. Everything is positive because both of these are positives. So my factors become 2x plus 1 and x plus 3, or x plus 3 and 2x plus 1. These do get a little bit more complicated because you have to find this factor here of what you're actually going to find the factors for. Okay, I'm going to factor 4x squared minus 9. So I'm going to start by drawing my graphic organizer. I'm going to put my 4x squared up here and my negative 9 here. I'm going to get some big numbers here in a second. The negative 9 is going to stay down here.
Nope. That's B.
No, that's B. Sorry, that's a 0. Thank you. Sorry. And I'm going to have negative 36 up here because this is A times C. So I want to know what number multiplies to give me, what two numbers multiply to give me a negative 36 and add to give me 0. And 6 times 6 is 36. And to get a 0, one of them needs to be a negative. So 6 minus 6 is 0. 6 times negative 6 is negative 36. So I'm going to get 6x, and I'm going to get negative 6x. So I look here and say, what do these two have in common? And I have 2x. And I look and say, what do these two have in common? And it's 3. And this is going to be a positive 3 because the sign for this number is what drives it through this particular pane of the box. Going this way, what do they have in common? They have a 2 and an x. And these have a 3, and it is negative 3 because I'm taking the sign that goes with this term. So I have 2x plus 3 times 2x minus 3, or 2x minus 3 times 2x plus 3.